Hello guys, how are you? So I'm going to show you how it is the implementation of this project. This project consists in PIC microcontrollers using also MPLAB, and you need also the PIC4 or PIC3 for send your program. No, you know. Here you have 5 volts. You need also 5 volts for this PIC. This PIC is bigger one because this is the PIC 16F877A. We need more ports for the display, the implementation of this display, and this is the PIC 16F676. Okay, so this is the most important project because it's for the control of timing switching of explosion. So you can switch these switches and have different times. Okay. Also in this project is very important the micro crystal is the oscillator, the crystal oscillator that is for our precision. Is expensive, very expensive this oscillator, but we need very precision in the times that we want for the explosion of mining. Okay, so when you switch the times, you're going to see, it's a simulation of course, you're going to see the dials, the switch on, blinking these dials, so you can simulate the explosion, and that's it. And also when you switch and you have an explosion, you can see the time that you have, that you want, because you switch in the display. You can see in the display your times. Okay, so we are going to see the project. This is okay, University of Zagreb, PIC time control by switched time display. This is the table implementation that is very important for know what I am doing. This is decimal numbers and binary numbers. The first thinking was in binary numbers. For example, if you switch on the first switch, we can see the picture. We turn on this switch that is already turned on here. You're going to have this time. This is 16.5 microseconds. Here is very clear how it is the implementation. That you have to set one switch set is the one, so you switch the first one and you're going to have this. It's very clear. So then we are doing this for 15 times, for 15 15 times. So you're going to have 9 seconds, for example, for the 15. Okay, then this is the secret diagram connections. I'm going to go, this is using the Proteus software, so I'm going to go for the Proteus software. This is all our project. So here this is the first project, so you can see the switches, the resistor that you have to have for the switch is very important, and the dials here. This is oscilloscope for see the square wave. Then this is the second project, doing the implementation of the display. We are reading the input. You can see, for example, this is turn on, turn off. This is the wire I am reading here, for example, REC2. And here is REC2 in this microcontroller also, so you can take a decision in this microcontroller about this one, about the times that you want, that you switch. Okay, For example, in the Proteus implementations, we can turn on and see, for example, all the switches are off. So if we go for the table for implementation, the decimal number 0 and binary numbers all in 0 are the 15.25 microseconds. So we turn on. We have to wait 2 seconds, and here you can see that you select 15 microseconds in time. This is the 0, all in 0. We are not going to see the dials blinking because it's very fast. This is microseconds, so the software can do it, and also for the software can do it. So this is why we are not seeing the dials. It's very fast. For example, we are going to try with another. This is the 8. For example, we put 10, the 10. Switch 2, switch 4 in 1. So now if we go for the table of implementation, the 10 is 125 milliseconds, so we are going to have this time. So now if we put play for another example, we wait 2 seconds, also for this one 2 seconds, and you select 125 milliseconds in time. That's very nice. It's working. So now MPLAB for see our code. What we have here. First, I'm going to close this. This is not important. Making no. This here, header file. This is the first project. PIC60. This is name. Switch point H. Where it is? Wait. Here it is. Okay. This is the configuration of the bits. The bit settings. So, for come here, you have to come here, configuration bit, and you came for here. So, I am using here the external oscillator. So for this microcontroller, this is the configuration. For the external oscillator, you have to go for the clock in. This is the important thing for our project. So we are not using all this. So this only is important. Put that you are using EC, that is the external oscillator, and you have to include this library for the configuration of the oscillation, the frequency. So you define your frequency that you have, that you want, and also we did in LabVIEW with different oscillators the comparison, and we obtain exactly the frequency that the oscillator give me. Where we can see this in a LabVIEW project in the computer. So this is the precision of our oscillator. Okay, we are going to go for the switch.c file. You have to include the libraries. It's important. This is internal libraries. This is our library, the header library. Our, you have to put exclamations, okay, for our libraries. So this is the main. You first define the input and the output of the register of the microcontroller. So when you put all in one, this is because you want to use switches, the input. We are going to use the switches like input. this is why all the GPIO-C is in one. Then we are using the output and the output registers, and this is the first step. Turn off the LEDs for don't have problems. Then you come for the while. We are waiting for have more precision, 2 seconds, and then for do only one time we define this variable, this starting true. So for example, you switch the case 64. This is the switch. So you put in 1, the last switch, and you're going to have the faster case is 0.4 microseconds. If you read in internet and you know how it is the why it is the faster case, this one of the microcontroller, you can see how it is the cycle of a microcontroller and why we have 0.4 microsecond like the faster case. Okay, so we are turn on the first LED and turn off both LED in the end and ready, and then start to false for do only one time and for not have problems. Then the cases, we repeat the cases, we have the same for different cases. For example, I don't know, if you you set 2 switches, 2 and 4 for example is the 125 milliseconds that I show you. We are doing a delay here, that the time that we want. We are calling this library. This is a library. For example, if you can see this library, this is the library. It's short library, so it's not using a lot of time for us. You have to know that when you have more libraries, you need more time, no, for read each line. Okay, this is the project. This is the first one, and then if we can go for the display project for the other microcontroller, and you can open the header file. Is the same, the configuration bit. The configuration for the external oscillator of 16 MHz. Here is 16. Sorry, I confused. We are using here is 16. Okay. It's not internal. We are using external. This is my fault. It's external here. So this is configuration bit. Then you can we need the library of LCD for the implementation with all the functions. Then you come for the source file, the .c file. This is bad again, sorry, because I changed the oscillator. We are using the 16 oscillator and it's external oscillator. External. Okay, you have to include the libraries, our header file, the pins of LCD operation, and then after you say which are your pins of operation of the LCD. You call the library of LCD. This is in exclamation, so it's our library, is in our project. This one. No, for example, boy LCD start is a function of this header file that we have. Then you came for the main, also again input and output. You define, and you come for the while, and we are doing the same. We are reading, and we decide, and we show in the display the times that we have, and that's it. It's very clear, I think. and you have to think that is two separate projects, but we have a connection for read the input of the first project of the times. Okay, this is the most important things. Here we are waiting 5 seconds for show the time that we obtain. You wait and then we go for false for stop. Okay, and that's it. This is the final, and we repeat all for all the switch that we set and ready. Okay, this, I think that all is clear, and I think that you're interested in do something like that. I'm going to give you down. I'm going to give you a Google Drive for download the project. That's it. So nice to see you, and see you then. Bye bye guys. Bye bye mentor. Hello guys, I forgot show you the result of my project. We can see in the 100 microseconds, very fast, the line we can see in the oscilloscope, and we obtain for when the first dial blink and turn off, and the second blink and turn off, we can see the value. Here is the value. I can well, okay, you can see measure, and under you can see value 2 seconds. This is this case is, I'm going to show you in the table. 2 seconds is the 12, is the 2 switch set 3 and 4, and is very the time that we want is very precision. We have a very good precision here. And okay, for example, for 5 seconds also we have a very good precision, and that's it. I'm going to do this comment with you, so is final. I final.